Hello everyone, let's continue our course. In this chapter, I will introduce about layer 2 switch. First, let's talk about bridging and switching. Actually, in the past, our device is called a bridge, not a switch. But now we call that is switch. L2 switch is working at the data link layer. When the packet is received by the physical layer, it will process by data link layer and process to another physical interface forwarding to another host. This is the working mechanism of the switch. We call that is MAC forwarding, MAC-based forwarding. When we talk about this, we need to know there's a MAC address table. In this table, for example, in this topology, there are 4 interfaces connect to this switch. Each host has a MAC address. When there's one frame forwarding by the host to switch, the switch will recording the source MAC address of each port. So it will learning this information and create this MAC address table like this. From port 1, it has MAC A and MAC B, like this for PC. Port 2, it has MAC C and MAC D. Next time, if the packet is forwarding to the MAC C, it will directly forwarding to port 2. Okay, we said it is source MAC learning. When a switch, for example, a switch is just power on, it has no MAC address table. But how to forwarding the packets? It will learning this information, this MAC address, and the mapping to all the port. The first packet received by switch will flooding to all the other interface and recording the source MAC address. Next time, if from the other side forwarding to this MAC, it will not flooding to all the other interface, directly go to this port 3. Okay, that is the source MAC learning. After a short time, the switch will learning all the host MAC address, and after that, it no need to flooding the frame to all the ports. This is called aging. In this page, we notice multiple PC connect to the switch as the previous page, and we have the MAC address table. But maybe later, after some minutes, because the PC is no one to use, maybe it's power off. This 2 PC power off. It will not exist in this network because no NIC card will reply any information. But how to keep this MAC address fresh? How to keep that fresh? It will use this aging mechanism. It will setting a learning aging time for each item in the MAC address table. For example, by default, our switch will have has 300 of seconds aging time. If one packet forwarding to this port, that means the port 3 is active and not aging. If there's 300 seconds not receiving any packets, not receiving any frame from this port, it will delete this item for this MAC address. So that is aging. It can keep the network security and keep the network stable. Keep all the MAC address fresh. Okay, and also devices may be moved from port to port, which could lead to traffic being sent out of the wrong port. Another reason. One reason is the PC is not exist. Another reason is they replace the ports. 3 switch modes. This is just for introduction. Cut through, the fastest. Store and forwarding, the safest. Fragment free. Actually, today by I think most of the switch will running as the store and forwarding mode, because now our hardware processing the frame very fast, so no need to think about the speed. It's all line speed forwarding. So this one more safest. This is better. Okay, another concept. Previous chapter we learned the collision domain. This is called the broadcast domain. The broadcast domain, we know what is broadcast, such as ARP request, this kind of packet from one PC forwarding to the switch or a hub, anyone. The switch will forwarding to all the other ports, because they belong to one broadcast domain. The switch by default not control the broadcast. All the port will in the same broadcast domain. In next course, I will introduce how to use VLAN to control the broadcast. In this chapter, we have learned source microlearning and aging. They are switch working mechanism, a broadcast domain. A switch is a broadcast domain, but it's still faster than hop. So the question is, why MAC address table needs aging? The answer will be to keep the address table fresh. When some port has been changed, some PC has power off, that example. That's all for this chapter. Thanks for watching.